Hello, everyone. Welcome to our book club. Today, we are delighted to welcome Owen Woods. He is a software architect, now working as a chief engineer at Endava, where he is responsible for capability development, innovation, and emerging technologies. He is also a regular conference speaker, has co-authored 3 books on software architecture, and today he will be talking about some key activities from his book, Continuous Architecture in Practice. Just before we start, a quick reminder to our viewers. In this session, we appreciate the questions, so please leave your questions in the YouTube chat so Owen can address them later. Owen, thanks for coming to our book club. It's all yours.
Thank you. It's very nice to be here. Thank you for the invitation. So I've given talks on continuous architecture quite a lot, and I think we really want this session to be much more about the Q&A than slides. But let's just set the scene as to what we're talking about, what continuous architecture is, and why we should care. Firstly, who am I? My name is Owen Woods. I've just realised this slide is slightly out of date. I'm actually Endava's chief engineer. Really just a change of job title rather than a change of role. I'm responsible for how we go about delivering our software projects to clients. So, for example, how we go about software architecture, but all the other disciplines as well, right from UX through to infrastructure and DevOps. Before I came to Endava, I spent about 10 years in the software product industry. That was mainly in the UK, but also in California. I spent 3 years in California. And I spent about 10 years then working for financial organizations. So I went from the products, creating the products, to the people who use the products, and did software architecture right through that in those different environments. I've always been one of those sort of technical people. I've been a software developer for years, and then moved into architecture as a natural evolution then. And I've written or co-authored, of course, some books on software architecture, and I've written various articles and been an editor and so on. You can find me via Google search because my name is very easy to find. It's an Irish name, in case you were wondering. The book I'm talking about today is the latest one that last but one that I've co-authored, Continuous Architecture in Practice. I co-authored it with 2 fantastic guys, Murat Erder and Pierre Pureur, who are very experienced software architects. Pierre worked for many, many years in the insurance industry, primarily in North America, and Murat has worked in financial services for about half his career, and the other half he worked in sort of thing I do now, professional services, doing great stuff for other people. It was published by Addison Wesley in 2021. We wrote it in late 2020 through to 2021, and very pleased to say it's been selling quite nicely since. So hopefully today we can delve into its content a little bit. So where did continuous architecture come from? Fascinatingly, a number of different people and different groups around the world had quite a similar thought at roughly the same time. And the reason is software development has changed from when I was in the industry. Agile working is now just a given. Agile helps teams to deliver value regularly. The old problem with that was the infrastructure often got in the way because the infrastructure teams couldn't change things very regularly for us. So releases got batched up while the infrastructure caught up. Then cloud infrastructure came along, then became mainstream. So now we can change the application quickly, we can change the infrastructure quickly. And then we realized actually changing big monolithic applications all the time is difficult. It's not it can't be done. Shopify, for example, are a walking example that it can be done. But many companies found it very difficult. And that led to the thinking about if we made our applications out of smaller pieces, we could change the smaller pieces more quickly and with less risk than we can a single big thing. The other thing that arrived was reusable cloud services. So we're not just using our own software, we're very dependent frequently on very sophisticated high-level services from cloud vendors. The most recent ones, of course, being AI services hidden behind APIs. And the people who hadn't really been part of the puzzle, if you like, until a bit late in the day were really the operations team. And that's when the DevOps movement started, realizing that if we're going to move really fast, then we're going to have to get good at operating things that change all the time. So that's going to require much, much closer, much more aligned working than we ever did before, and much more fluid responsibilities. And that, of course, is what DevOps is all about. Cross-functional teams taking full accountability for the software that they're developing. None of this is new. You're probably wondering why I'm telling you. The reason is because the implications of that, although they're not necessarily spelt out by any of those movements, is software architecture, the architectural system, becomes much more fluid It evolves a lot more than it did 20 years ago when I started doing software architecture. So the obvious question is, do we still need architecture? Is it still valuable? As a career architect, you might not be surprised to know that my answer is a resounding yes. Of course, it's still important, but there are reasons for that, and the reasons are really in the picture. Quality attributes, that's the non-functionals as they're also known, they're absolutely crucial to the success of most systems. But one of the things, if you've got high-performing Scrum teams, development teams, developing features for product owners, they find it very difficult to do, is to ensure that the quality attributes of the whole system are going to be acceptable. You can't really say to one Scrum team, can you make sure that we're secure, whatever that means, or um, the system needs to be scalable. They could work on their part and they could make it scalable, but these things go right across the system and they require a systemic view to achieve them. Second thing is lots of people care about our system. An awful lot of software development practice is centered around the idea of a product owner and team. And the product owner very good at what they do. The team is very good at what they do, developing the software. The two work together symbiotically, and a flow of valuable software emerges. And that's great, except that in nearly every organization, there's an awful lot more people involved than the product owner and the development team. We've just mentioned one. There's probably some sort of IT organization. Even if you're doing DevOps, there's some sort of organization is accountable for all of the IT infrastructure, security, cybersecurity response, all those things. There's probably somebody, or maybe not one person, but a group involved in business continuity management. That is, what does the business do to continue operating if there's a catastrophic problem like total loss of power to a city or something like that. There are people perhaps involved in regulatory, or there are people involved in marketing who are very interested in your system. There's probably an internal audit group. Lots and lots of people care about your system. And one of the things I've really seen that development teams find difficult to do is to work with a range of people who've got various different interests in their system, some positive, some a bit less positive, and balance all those concerns. In theory, the product owner just does it, but in reality, most product owners are very focused on delivering probably features, to be honest, for their particular part of the business. And so they don't really do it either. And they might well not have the technical knowledge to do it. So balancing stakeholder concerns, that's something we've got to do still as well. And we're constantly, every design decision that we make in the system has trade-offs. And there's often no obvious right answer. There may not be an obvious good answer. I've often joked that being a software architect means making decisions that are the least worst in a situation, the least worst option possible. But complex trade-offs is really inherent to what we do. So for all these reasons, I would say that we're constantly dealing with what I call cross-cutting concerns. So we're dealing with things that affect all of the system, all the different bits of the system, sort of at the same time. And that's very, very hard to sort of delegate responsibility for to teams who are either working on a part of the system or a value stream, because they just haven't got a combination of view and authority and knowledge to actually make those things happen. So I would argue architecture is still very important, but it needs to change from being something where we do a lot of designs up front and we draw complicated diagrams and then we put them on the wall and everyone kind of looks at them and ponders what they mean for them, and we sort of blueprint driven architecture, to something where we're design decision driven architecture. It's actually the decisions are the really interesting thing. The models, the overall architecture is the side effect of making the decisions. Back in 2013, maybe earlier, Murat and Pierre had known each other for many years, and they were in these two big organizations. And they saw lots of people who were really rather good at software architecture and design, finding this changing environment became quite difficult. And they found it difficult to work out how to reinvent their work to make sure that it was just as effective now as it had been before things like cloud and cloud services and DevOps came along. They identified 6 principles that would be valuable to guide the work of people doing architecture and design. Principle 1 today sounds very obvious. Most people today think about products. But back in 2010, 2011, most people in certainly enterprise software were actually thinking about projects, and that you assemble teams to do a project. and then reassemble a new team to do the next project. And they said that's partly what goes wrong in all this. You need the continuity, you need the history, you need the context that product thinking gives you. So that was their first principle. The second principle was about quality attributes. It's the functional requirements will largely take care of themselves because high performing teams with good product owners will meet the functional requirements. As we've said, what they will find very difficult to do is to meet the quality attributes. So whoever's doing architecture and design work, obsess about the quality attributes. Principle 3 was delay design decisions until you absolutely have to. There's a natural inclination to make a decision as early as possible because it's an unknown and we don't like unknowns. The problem is the earlier you make a decision, the less you know. The later you make a decision, the more you know. The more you know, the better a decision you're likely to make. So that's why they say delay design decisions until you actually need them. That doesn't mean procrastinate and don't make decisions or make decisions so late that everyone's moved on and ignores you. But it does mean don't rush into making decisions until you can see that they're actually needed. Maximize your chances of success by maximizing the information that you've got available. Principle 4 relates to that whole microservices and serverless movement, except that it's more general. It's bear in mind that your system has to change. There was a time we kidded ourselves that we sort of knew what the system had to do, so we just built it and then it went into maintenance mode. And what they're pointing at is those days are gone forever. Healthy, successful systems now change all the time and sometimes change in quite dramatic ways. So think about how you enable the system to change. How do you enable development teams to be able to change the system easily in your design thinking? And their tagline for that is leverage the power of small, by which they mean if you create a system out of smaller parts, and they're not necessarily saying microservices, but they're saying if you break up your monolithic systems into smaller parts, then you're more likely to be able to support change effectively. Principle 5 is all about value in software engineering. There has been a tendency historically to think that our work is done when the software is developed, not operating, developed. And then somebody else will look after the rest of it. And they point out, actually, until it's running in operation, it's not valuable to anyone. So they say architect for build, test, deploy, and operate. Because if you're going to change things regularly, you'd better get good at dealing with change. And that means you need to be able to build it quickly, reliably, and efficiently. You need to be able to test it very rapidly to a very high degree of confidence. You need to be able to deploy it at low risk very rapidly, very frequently. And you need to be able to operate it in an environment where it is changing all the time. And all of those require architectural thinking. You may not be doing all that architectural thinking, but you need to make sure all that architectural thinking is done. And finally, bear in mind that the structure of your system and the structure of your organization are highly related. They're highly dependent on each other. So model the organization of the teams over the structure of the system that you want. We don't talk much more about that either in this book, which is on the right, or in the Continuous Architecture and Practice book. What we do these days, we point to team topologies, as we found that the team topologies book is the best model and the most effective organizational advice that we have found, for how to organize software teams for success. And so in 2015, they wrote these principles, and based on the principles, they wrote the first book on continuous architecture. And that book is a little bit more why and what rather than how. And the continuous architecture and practice book, I got involved at that point, it's much more the how. Because the question people always ask is, what do I actually do? These seem like great principles, but what do I actually do with the teams? The answer is that there's 5 practices we think are very important for people doing continuous architecture. And they are to provide leadership, to focus on the quality attributes, as we've mentioned, to drive architectural decisions, and note I say drive, to manage technical debt, actively manage technical debt, and to implement feedback loops. Let me talk very briefly about those. Providing leadership is not managing the team. I describe leadership as being the technical conscience of the team. It's about always driving the team towards technical excellence. And some of the ways that people do that, for example, are to form technical leadership teams across an entire system and lead those teams to make sure that there's good alignment across the teams and that all of the people who are technically influential are working together, aligning their thinking, and agree how the system works. It's also sometimes about leading the team to make hard decisions, and it's sometimes about reflecting reality upwards or sideways or wherever it has to go that's outside the team. Perhaps that's the product owner conversation that nobody wants to have. Perhaps that's going up with the product owner to a product manager and explaining why something can't be done in a certain time. Perhaps that's going to the regulatory compliance group and explaining that what they're asking for is going to be very expensive and slow everything down for 6 months. And is that really what they want? It's those kind of conversations. So it's technical conscience, it's providing example, it's organizing technical leaders within the team, and it's being the person who's prepared to have difficult conversations when they need to. Second one is focused on quality attributes. We've talked a bit about that. The teams will find it difficult to achieve systemic quality attributes without a lot of cooperation and working together. And this is where that technical leadership group is absolutely crucial. You can have champions for different quality attributes in there, and they can be aware of that quality attribute right across the system. And then they're working, if necessary, with all the teams. They're maybe making some decisions to enable that quality attribute, thinking about the trade-offs, and then working with the teams to implement that. The third practice is to drive architectural decisions. Note it says drive. That's not the same as make all. In fact, arguably, if you have an architect, and I'm not suggesting you need an architect, you need people doing architecture work. But if you do have an architect who is leading the technical leadership team, for example, they would their aim should be to minimize the number of architectural decisions that they're making themselves. Their aim should be to maximize the number of good architectural decisions that are made. And a couple of key practices around that are making sure that people are making architectural decisions in good time, being aware of what decisions are needed but have not yet been made and working out when they should be made, making sure decisions are captured well, they're curated, and that they're reviewed on an occasional basis. We've all been into project teams and they've said all our documentation's on the wiki, and you say great, and you start reading, and they suddenly after an hour they come over to you and say, oh, don't worry about the stuff on how we do data ingest, that's all changed. I'll get someone to explain it to you. And then someone else says, oh, the bit about pipelines isn't quite right, but it's sort of how we do it, but actually we've changed which parts of Azure DevOps we use because we found we got better performance doing it this way. And after a while, you wonder what's true and what's not. And with architectural decisions, super, super important. If a decision is no longer true, then move it to the archive. It's useful history, and perhaps link it to a decision that superseded it, but make sure that people don't think that's the current decision. Then talk about managing technical debt. I have observed that teams are not bad typically at identifying technical debt if they're encouraged to do so, but they do find it difficult to keep it under control. And there's a couple of reasons for that. One is it's a rare product owner that prioritizes technical debt without somebody sitting them down and explaining why they need to. Secondly, the implications of technical debt are not always clear when it's identified. Yes, it would be better in some abstract world if we were to, for example, have a more modular design here, or rather than hard-coded logic, we had something like a chain of decorators. But what's the actual implication? What this is all about is encouraging people to spot technical debt, making sure it's recorded, and making sure you understand the implications so that you can be advising, particularly non-technical business people, what that technical debt means to them and why perhaps they should be thinking hard about how they repay it. And obviously there are different strategies for repaying it. You can negotiate with the business that, say, 15% of effort in every sprint is going to be used to do. I actually describe it as technical improvement rather than repaying debt, which sounds a bit negative, but technical improvement. Or you could decide that we are going to identify certain periods of the project cycle where we have less velocity and we sort of do more repayment. Or indeed, it can be valid to just say, we're just going to let it pile up. And when it stops us doing stuff, we're just going to stop everything else and just madly repay debt for a couple of sprints. The problem with that one is it tends to be the one the business like the sound of until you tell them that they can't have any features for 6 months. And then suddenly they realize what the implications were. So they all need explained carefully. My point would be if technical leaders, such as the technical leadership team and architects, are not actively managing technical debt, no one else will. And technical debt, more than anything else, is what gets the business people frustrated with us because they cannot understand that their decisions have caused the current state that means the team's velocity is low and their reliability has dropped. And so that's why it's so important to manage that. And the last one is implement feedback loops. The whole point of doing something continuously is so that you can adapt and change based on experience. That's great, but how do you know what to adapt and what to change? You need a feedback loop. Building feedback loops sounds really straightforward. There's not actually that much about it in the book. I'll actually confess that now. We didn't have that much to say at the time. We sort of make a lot of perhaps somewhat obvious statements about start small, don't overcomplicate it, make sure you prioritize the most valuable feedback, blah, blah, blah. The reason is I have observed that feedback looks deceptively simple, and actually creating effective feedback loops particularly for complicated things is actually very difficult. That's why actually at the GSAS conference, Appium Hubs conference last autumn, I actually developed a talk just on feedback loops, which is perhaps a slightly esoteric topic for a talk, but it's because I keep observing that feedback loops is a problem that looks much simpler than it really is, and actually achieving good ones is quite difficult. So I'm not going to talk much more about that right now, but suffice to say, implementing feedback loops is actually a really important part of continuous architecture. If you haven't got the feedback loops, you can't capitalize on the fact you're doing it continuously to adapt and change what you're doing to optimize the value delivery and optimize the technical work that you're doing. There's various books. That's as much as I'm going to say about continuous architecture this morning. Hopefully, you've got lots of questions. Finding out more. There's the first book, as I say, just called Continuous Architecture, and it's more why should you do continuous architecture and what is it? And then quite a lot of people read it and said to Murat and Pierre, this is fine, but what do I actually do? And so that's why we wrote Continuous Architecture in Practice. It's a bit more, here's how you do it. And we think in particularly about some of the key quality attributes and how you go about achieving those in a continuous kind of environment. Two, if you're starting off with introducing design or trying to improve design and architecture in teams, two books which are really good, which one predates continuous architecture and one was sort of in the middle. George Fairbanks's book is now quite old. It's called Just Enough Software Architecture, but it's still an absolute, and it's all about being risk driven in how you apply it. George has been at Google for many years. He actually wrote this before he went to Google, but he improves their software design practice among many other things, I think. But his book's very interesting because it's all about how you bring good design practice into teams in a way that motivates the team to do it, and also it's just the right amount for the position they're at. And then Michael Keeling, who, funnily enough, is really great friends with George Fairbanks. I don't think that's an accident. Wrote a book with a similar kind of message, but perhaps just slightly different, slightly broader spectrum, and perhaps just a few more techniques in it, called Design It for the Pragmatic Programmers. Neither of those books talks about continuous architecture, and yet both of them are very supportive of the ideas. They both, they both talk about the need to iterate and do things incrementally and get feedback and so on. So they're great books. Two continuous architecture books are really aimed at people who do architecture and view architecture as part of their role. Those other two books are much more aimed at people who view themselves as software developers and teams, but are thinking we must get better at design than this. There are better ways to do it. And then team topologies, which I mentioned. Principle 6, remember that your team structure affects your software structure. And that's what team topologies is all about. Two websites. Remember I mentioned there were multiple people coming up with these ideas. So George and Michael, had similar ideas together and independently. Murat and Pierre had their idea. The top website, continuousarchitecture.com, is run by a French consultancy company and the Michelin Group, the French industrial conglomerate. They had a very similar idea at roughly the same time as Murat and Pierre, designed their own internal approach, and they've open sourced quite a lot of their materials, and they've got a website on how they do continuous architecture. Then the one at the bottom is specifically the book for continuous architecture. Specifically the website for continuous architecture in practice. The two websites kind of reference each other. There's loose, friendly relationship, there's no actual joint working to kind of merge the specific materials. But it's striking that when you read the two sites about where all this came from, it's exactly the same motivation, and they've come to many of the same conclusions, which makes me think perhaps we're not mad after all. And there are a few other books which I'm not going to go into here, but they've got specific content in them, which is interesting, relating to some of those different activities that we just talked about. So that's all I wanted to present. This isn't meant to be really a slideware session, so I'm very interested in any questions and discussion points that people have at that point.
Thank you very much, Owen. I think there are a few questions that people is asking. For practitioners looking to implement continuous architecture in their organizations, what advice would you offer to ensure a smooth transition and successful adoption?
That's really interesting. We've been talking to some Endava clients about that. Of course, we do use continuous architecture in some of our projects. I think work out what it is that you don't like about your current implementation and start from there. Why do you think you need continuous architecture? Because presumably something's not working exactly the way you think it should. So I would always start from there. I would start to think about using design decisions as one of your key architectural artifacts and really get good at doing design decisions. You don't need to work continuously to use design decisions, but they're a great enabler. Start thinking about that. And then start to look at start to think about the principles. Which of these principles do we already live? You might well be a product-centric organization, or perhaps your teams are absolutely brilliant at designing for build, test, deploy, operate, or maybe they're not. I mean, look over those for maybe the areas of improvement. And then in terms of how you want the designers to be working, that's where you go to the activities and you sort of think, so we probably can't start all 5 of these at once, but we know that they're probably all important because they all contribute to the goal. This, say, the next couple of months, which one of these are we going to do a bit of thinking about, do some reading, maybe a bit of a book club thing, and then think about how are we going to start implementing these practices. And then actually what I've observed is quite often it sort of takes on a life of its own afterwards, because none of this is very complicated and it all fits together. It's not sort of like safe. It's not some huge complicated framework you take years to understand and learn. The practices and the principles sort of support each other. So if you're thinking about um, architecting for change, you're probably going to be thinking about technical debt. So suddenly the technical debt practice kind of leaps into life. And so the other thing is, I think don't force it too fast. Some people will probably view this as pretty obvious, and they've been doing it quietly, bits of it quietly themselves for quite a long time. And yeah, if you want to all be working like this, I'd be thrilled. And then some people will be going, this all just feels a bit unnecessary or very unnatural, or for some people, Pierre's had a lot of this where he works. I'm losing control. There's too much risk. I don't understand how to manage my risk, and so um, different people will have different reactions to it. So go at the speed where you're getting benefit, and nobody's sort of jumping off the train and deciding that this is either very threatening or is going to cause them a big problem. Because if we force things when people think they're going to cause a big problem and problems occur, inevitably that kills the whole thing.
That's right. Okay, thank you. We have 3 more questions. As architects adopt continuous architecture principles, how do you suggest they measure success? Are there any specific metrics or KPIs they should focus on?
Yeah, that's a great question. That's probably another chapter in the second edition, actually, is measuring success. We don't talk a lot about that. I think part of the problem is the principles are quite abstract, and they need interpreted in a particular context. So, for example, focusing on quality attributes, there's loads of KPIs around quality attributes. The problem is which ones make sense for you. I mean, the advice we could give is for the common quality attributes: scalability, performance, resilience, evolution. Here's some useful KPIs and measurement approaches that we could suggest, but which ones would you use? That sort of would be up to you. So a lot of that is out there. although I completely accept it's a bit scattered. It's not really in one place. I think things like the whole architecting for change, architect for build, test, deploy, operate. I think you measure that with velocity, with the DORA metrics. So cycle time, time to recover, reliability. It's those kind of things that you would measure with that. And in terms of modeling the organization structure along with the system, I think that is best measured in actually with surveys of people. You can use these days organizations like Microsoft, where so much of our stuff goes through Microsoft products on the cloud. They can present you with lots of organizational metrics, which is quite interesting. For example, if there's an awful lot of communication between some teams who you think shouldn't be having to communicate, that can highlight problems, and that can be a useful KPI. Is cross team uh, volume of cross team communication, but really it's how the people are feeling, how effective they're feeling. Do they think they're getting blocked? Again, you can derive some of it from Jira, but I think for the organizational stuff, it's just much more powerful to go to the people and have a well-constructed questionnaire. You might get external help to do a really good questionnaire, but maybe a local university. They would be fascinated to work with you on that. But it's questionnaires really, because so much of the organization stuff is about the way people behave and the way people feel working in the organization.
All right. Let's go with the third one. How do you recommend architects stay ahead of the curve and effectively incorporate emerging technologies into their architectural practices?
Oh, that's a great question. Yes. Well, I think architects need to read a lot, and they need to do a lot of prototype coding so that they understand how things work. I've been spending an amount of time that has surprised me on various generative AI technology. I've been brushing up my Python recently because it all seems to be driven by Python, whether we like it or not. So I think, if possible, just sort of work in the teams and do horizon scanning and like that. But for lots of people who are in leadership positions, that's just not practical, because if you've got stuff on the backlog, you become on the critical path, and it just takes too much of your time. So yeah, what I do really is that I do read a lot. I attend some events such as Software Architecture Summit, which is a great event in Europe. Um, um, and I'm on a number of newsletter distributions, particularly for fast-moving areas. And there's various sites, the InfoQs and sites like that, where you see things emerge. I'd almost say the important thing is actually not to overreact when you see a trend emerging. Um, there's not always, but it is rare in my experience. There's a huge amount of business value by being a first mover. I mean, a real kind of bleeding edge first mover in too much of this. It may be interesting, but did the business get a lot of benefit from it? Perhaps, but actually, I think it's often the second or third wave people get the most. So um, that means that don't see something and immediately decide to implement it, but you do see something and then assess it. Some people use internal technology radars, for example. ThoughtWorks people have had those for a long time. The very important thing there is, though, that they're in your business context. The ThoughtWorks stuff, remember, is not in your business context. It's stuff they think is interesting, or they've seen in consultancy, perhaps, or they've seen people prototyping. It's not necessarily stuff relevant to your business. So using the same approach of, or some do your own hype cycle or whatever it is. What have we seen that we should be investigating? What have we investigated that's actually worth doing some prototyping with? What prototyping stuff should we be using in pilot operation? Which pilot stuff has just been knockout successful, and we should be making the investment to roll that out. And I think that sort of approach is the way that works best. One thing that I have often advised people I've mentored to do is to block out time in your diary every week for learning and research and that sort of work. It's very easy if you're in a technical leadership position, say you're a principal engineer or even a senior engineer in a team, that you're interrupt driven a lot. People need your help, they need your advice, or you see something and you need to intervene. And that's the way it is. I mean that's the job. Um, Having a blocked out bit of time, like a Monday morning, a Monday afternoon, a Friday morning, whatever it is, where if there's an emergency, clearly you'll be flexible, but most weeks people know that you're in do not disturb mode, and you are, doing other things, whatever that is. That can be really valuable, and you can look back, and especially if you get interrupted, delete it from your calendar. So then look back over your calendar every 6 or 8 weeks and go, how much time have I managed to devote to the learning, stroke self-development, stroke horizon scanning, stroke prototyping that the organization needs? This isn't really optional; it needs it. So if it's not happening, then you can raise that um, other than total emergencies, you shouldn't be disturbed on a Friday morning, or you find someone else to handle the stuff on a Friday morning. That would be my advice. It's be aware what's out there, keep up to date to a certain, or keep your understanding up to date by just enough practical work that you understand how the nuts and bolts work, and then think about phasing for things from on the horizon we don't care through to we're ready to go with it, and then block out bits of time so that on a very regular basis, so that people know what it is, to make sure that it doesn't just get crowded out by day-to-day work.
All right, pretty good, useful tricks. I think we have the last one, if I'm not mistaken, is also related to the emerging technologies. Are there any emerging technologies or methodologies that you believe will have a significant impact on how architects approach their work?
That's a great question. I think architecture practice evolves pretty slowly, honestly. If you look at design decisions, I told the story at a conference recently, and then slightly bizarrely, a few weeks later, met the man I'd been talking about. Um, I think it was 1995 or 1997. An academic called Jan Bosch. He's had a dual track career. He had a very successful career in academia. He moved to industry, and now he's back in the university sector again in Sweden. Jan gave a talk at an academic conference about why we all had it wrong. We were all doing the wrong research. Decisions were important, not structures. And we all kind of went, huh? Everyone just kind of moved on. And then he did a bit more on it, but then he sort of left it. And then the academic community, some years later, I think it was early 2000s actually, Philippe Cruchten and Patricia Largo and others picked up this idea. Oh yeah, decisions, they are quite important. And they talked to a lot of practitioners, and they did lots of thinking about what's a good decision, what's its structure, where's it used, what kinds are they. They did all that. And then finally, design decisions started becoming popular about 2015. So these things have a long gestation. So in terms of what might hit us, I think in the next couple of years, I think I meet more and more people now who are asking for two things. One is, you talk about patterns and styles quite a bit. People seem to have forgotten they even exist. How do we bring patterns and styles back into normal use? And Mark Richards and Neil Ford's book has quite a lot on patterns and styles. To be clear, they're not brand new things. I mean, those patterns and styles have been in books for 20, 25 years. But if you just wanted somewhere to go, that's one of the books that has recently tried to repopularize them. I think that's one thing. The other thing which I'm hearing from a diverse group of people is we seem to have sort of lost the ability to describe our systems well, particularly visually. And of course, C4 is Simon Brown's answer to that, which is this is simple, lightweight, pragmatic. And people say, yes, the problem is people look at the notation and go, I'm happy to use that, and then find it very difficult to actually build the models. I think it's because a lot of universities have dropped modeling, particularly visual modeling, out of their syllabuses because it wasn't seen as relevant by industry. And actually, this is the baby and the bathwater, as we say in English. We've thrown the baby out of the window with the bathwater. Is that UML may or may not be useful. Modeling is useful because that's how we understand and conquer complexity. And unfortunately, I think a lot of universities have actually dropped modeling, other than sometimes quite obtuse mathematical modeling, out of the syllabuses. A lot of people have never seen it. So I think that's another trend is emerging. Those two, we sort of know how to do. They've been there forever in a sense, but we need to remind ourselves of their value and how to do them. The third one, which I think is interesting and far trendier, is applying generative AI to architecture knowledge. I've heard of a couple of people trying to do this. One of the really challenging things at the moment is that a lot of the generative AI models people are using are really good at processing text. So RAG systems are basically based on text today, or most of the ones I've seen. An awful lot of architecture knowledge is in pictures, it's in diagrams, sometimes without very clear notational guides. So I think one of the challenges we've got is how we supply either train a unique model. There are some academics trying to do this at the moment. I know some in the Netherlands and Italy trying to train base models on architectural data, and that's one of their challenges. But even if we're trying to use a generic large language model with our architectural knowledge base, think how much of that is pictures, formal or informal, big or small, but there's a lot of pictures. And right now, that doesn't seem to work very well. And we've tried this at Endava, and it really is a bit of a problem. One person I did hear who was having a lot of success with it was somebody who worked for a cloud consultancy. They do effectively well architected reviews. And he said the thing that they didn't really think about at the time, but has worked really well for them, is that all of their reports are in a very standard format. They've got exactly the same headers. They cover roughly the same ground. A lot of it is textual and tables. They do draw some pictures, but there's an awful lot of information, text and tables. And he said that it's not perfect, but it has proved to be useful. They've got now a searchable vectorized database of all of their old reports, and they have got an RNG system based on top of it where they ask it questions about, have we ever worked with Amazon Cloud Service X in in the pharmaceutical industry, and how did we keep the data safe? And it up till now, everyone just sits and thinks and say, yeah, didn't we do something for that company? And actually, it's not perfect, but it's definitely helping. The question is, can we go beyond that and ask large language models to generate us particularly diagrammatic versions of certain kinds of systems? And the answer is, based on the generic models, they're not so good at diagrams yet, but yes, to some degree. I think they're missing the nuances. If you wanted to make a trade-off, it's not very good at that. But in terms of building architectural knowledge in people, I think applying large language model technology to architectural knowledge is a fairly obvious thing to investigate. It's not very far advanced at the moment, but I think that will be interesting.
All right, thank you very much for your comments. I think it has been pretty insightful talk. I don't think we have more questions. No. So thank you very much, Eoin. Thank you very much for your time. It was an absolute pleasure, and thank you very much for those who participated. We'll be announcing some initiatives soon, so we'll keep you posted. Please subscribe to the YouTube channel, and Eoin, thank you very much again. Hope to see you again in the future. Have a nice day.
Thanks for the invitation. Thank you, everybody, for attending. Bye-bye.
Bye.